The topic of criteria for economic model selection, because in econometric there are a lot of model. Sometimes we are unsure on which model to use and under what scenario use which model, right? Here for me, I think the best consideration is the three general consideration. First, the data itself, right? What data do you have, right? And then, of course, you have to depend on the theory and your objective, right? Because you have to do a research, either you publish a paper or write a thesis, you have to fulfill your objective. So can your method actually help you to fulfill your objective, answer your research question or not, right? So in terms of data, you can see we have generally primary data and secondary data, right? In primary data, you can do qualitative research like interview. Why? Because by nature or by theory, sometimes we need some open-end question. Like let's say you want to do on aging workforce, right? So you want to know this company why they do not really encourage aging workforce in their company, or why they really encourage the aging workforce in the company. What policy do they have for doing so? So this policy, their reason should be an open-end question. It cannot be it's not so good to restrict them into a Likert scale 1, 2, 3, 4, right? So therefore interview question, right? So right, then you have to use interview question qualitative, or sometimes it's even to be more easier. You can put it in a like a scale. 1 is the most disagree, 7 is the most agree. So in this case, you also have primary data. You go through the survey, you send questionnaire, then but you get the result in terms of 1, 2, 3, 4, 5, 6, 7. So it's quantitative. You quantify people opinion, like how much do you like to drink coffee? 1 is completely dislike, 10 is extremely light. So in between it may be 2, 3, 4, 5, 6, 7, 8, 9, right? Then of course you have a mixed method, because quantitative cannot tell you all the story. Qualitative sometimes cannot capture many information because it takes time for interview and subjective question. So you may have a mixed method. Therefore, the type of data will determine what type of method you want to use, right? So, and of course, what you also have to consider, what is your objective. Like for example, you want to know the policy they apply. So in this case, you cannot use questionnaire, right? Or you want to test some existing model that you can quantify it, then you can use this one. So again, objective and theoretical and type of data, actually they come hand in hand in choosing model. Because most of my research is done on secondary data, time series, and panel data. So I'll focus more on the part B lah, right? For the secondary data mean what? Mean that those data already been there, right? We just take the data to analyze, right? For example, most common source will be the World Bank, right? For economics, for finance, right? For social science, we take from the World Bank. For the statistical department of the country, right? Then second data, you can have few type. One is time series. That means one country, many years. Let's say Malaysia, you take from 1970 to 2026 or 1990 to 2023. So one country or one company, many years. Cross section is just 1 year, but many country or many firm. For example, you take 2023, right? You take all the firm listed in the stock market in Malaysia, or all the firm listed as a finance sector in the stock market in Bursa KL, right? So you take a lot of firm, a lot of country, but 1 year. Panel is a combined. There are some model for special consideration we'll think later on, right? So, in this case, you can be panel or can be time series, right? Then of course, characteristic of data. Especially in time series, we will study stationary, right? If this data is not stationary, then how? Cannot be like I don't want to do, right? Of course, you have some other method that do not need the assumption of stationary, right? Or different character. Then of course, residual and data behavior, this most likely refer to your diagnostic test. If, like example, you have heterocaricity, you have autocorrection, then you have to adjust your method accordingly. Like you want to go from let's say one place to another place, usually you use car, right? But if extremely traffic jam, it's better to use motorbike. Or if raining, then it's better to use car. So you'll see that the diagnosis test and then depend on which model you use, right? Then of course, again, based on the theoretical requirement and your objective, right? For example, of course, there are million of theoretical requirements. So in economics, usually we have this called endogeneity, right? Because their dynamic effect, what is the GDP for today affect GDP tomorrow, especially inflation, for example. Inflation for this year is most likely affected by inflation for last year. If last year's a high inflation, then next year will be this year will be high inflation as well, right? What structural break in finance, because sometimes you do with volatility, high volume of data, so you most likely have volatility clustering and autocorrection. So if theoretically, right, let's say you want to do a stock market, right, theoretically, it mentioned to you your model or your theory has volatility clustering, so therefore you cannot use what type of model and you have to use this type of model, right? So we'll go in detail one by one, but of course we focus on the secondary data. Okay, firstly, the most common time series method will be a choose between this field, VAR, VCM, and ARDL. How to differentiate this field? Mainstream model is first we have to do the stationary test, right? The unit root test, right? That's why this is time series, right? So time series, we have a lot of time, right? So if the data or the series is random, that means just like a random pick, right? Like randomly, I mean, you will not be able to know or predict or have a relationship of the next one based on the previous data. So therefore, you need to take a stationary test, and the outcome of a stationary test will help you to select which model is the best. Right? So if your stationary test get all are stationary at level 4, that means I0. If for economic and finance variable or finance research, I think this one is quite rare, lah, right? I mean, all are level 4. Level 4 mean you no need to differentiate that data. You just do the unit test as is it, and it's all stationary. So if this is the case, you can use VAR or vector auto regression in level 4, right? But be extra careful is if you choose this model because of all variable in level form, the order of the variable is important if you use for structure analysis. That means you want to see how a shock, how one variable change give a shock to another variable, right? In this case, the ordering, the most exogenous order, that means the most low variable like GDP, 1 year once only, right? You put on the top, and then the highest, the most fast changing variable or most endogenous you put at the bottom, right? Now, because most likely it's not zero, most likely you'll get all variable stationary at level 1, that means first different. Of course, if first different is acceptable, right, you can do VAR with first different if all variable are first different. But usually, first different do not give much meaning to economic or finance modeling, because first different mean year t minus year t minus 1, right? You minus 1. That means you are taking the different. You may not fulfill your objective and theory, in this case, right? But if you have all variable in stationary one and they are with co-integration, then you can use VECM model, vector error correction model. From my experience, usually you most likely have co-integration vector. At least you have one. So if you have one, that means you can do. What does this mean? That means in a level form, let's say you have 3 variable. These 3 variable are quite random. You don't know their trend, but they won't go far from each other, right? They are co-integrated. So at one time, they will converge then through an error correction term. So if you have stationary at I1 with co-integration, you can use a lot of co-integration tests, right? Then it's good to choose VECM because VECM model can capture the short run changes, which is the different term, because it's I1, right? And also the long-term equilibrium through an error correction term. Later on we see this one. Okay? But most likely or sometime you get a mixture of I0 and I1. Right? But if you get a mixture of I0 and I1, some journal might also say that you can still use VECM if there is a co-integration, right, between the variable, right? At least a co-integration. But anyway, you can also choose to use ARDL, auto-regressive distributed lag. So from here, auto-regressive distributed lag, auto-regressive means the Y actually got lag term, distributed lag means the X got lag term, right? So it's the best model for a mixture of I0 and I1. Not only because of this, ARDL has some advantage over the others if you have small sample size, right? Because you bootstrapping it, more sample size is more preferable to use ARDL, right? And the presence of lag effect and autocorrection. Why? Because I mentioned just now, auto-regressive means you take into consideration of autocorrection, the impact of the previous Y, and distributed lag, you also take into consideration of the impact of the past X or X variable. Okay. So far is right. So we see the appendix 3. So if you see from here, right, you can also use this one is I compile from other information, right? AI and my own experience, right? Maybe I'll give you this one file also later on. VAR, so you see for forecasting, factor analysis, right? All these things. For example, I think this one much. So for if you were to use for VAR, it's not okay if you want to use for structural IRF, right? Impulse response function. Okay? Then what is situation when you use VECM? So here you can have some real example. Okay, some real world example is the Federal Model Stock Market. So in this case, the stock price and bond yield price fluctuate widely daily, right? So in this case, you must see that sometimes the stock price, previous stock price actually will affect of today's stock price as well, right? One of the, if you say the economic scenario is the inflation, right? Previous inflation actually can affect your current inflation. Therefore, other model may not be able to capture. So you have to use the VCM or ARDL. Okay? Okay. Next, in econometric, right? Sometimes people think that the more complicated the model they use is better, right? To show that they can capture everything, they take into control of everything. But actually, the most simple one is the best, right? It's just like you want to go to buy something at a shop just opposite your house. The best is just to walk over, right? You will need to drive a car, do a turn 3 round, and then only you arrive there, right? Right? So in this case, the most simple method is the best. But sometimes the most simple method is not that easy to use because it need to fulfill a lot of term and condition. In econometric, the most simple method is ordinary least square. That's why in your thesis, right, in degree of postgraduate thesis, you usually start with OLS as your benchmark model, right? Then you test the OLS. If all conditions are fulfilled, including I0 and large sample size, right? No heterogeneity, no multi-collinearity, everything, no autocorrelation, every diagnosis test is also good, then OLS is the best model. But practically, not easy to fulfill all this, right? So if it's not fulfilled, then how? You can change, right? To like just now, either you use a VAR, VCM, or ARDL. And also, maybe you would like to see the impact of by theory, like just I mentioned, by theory, your model or your research do point out that past data or past variable experience, right, will affect this year. I mean the lag variable X, the lag variable Y experience. So in this case, you choose the ARDL, not because it's a mixture of I0 and I1. Of course, you have to fulfill this one also, right? Because of the theoretical requirement, right? But if a theoretical require you use VAR, but you cannot achieve this condition, also cannot. That's why you have to take into consideration not only the type of data, the characteristic of data, but also the theoretical requirement, and make sure that any model that you choose can help you to achieve your objective, right? That is the most important. Either in your thesis or in a paper you write, you have objectives, and then at the end, you do a research, you do a regression, you collect data, you run a model, you also must be fulfill your objective. So if this OLS condition not met, for example, the most common one is a dynamic condition or endogeneity, right? By theory, right, or by testing, diagnosis testing is not met, then you can modify this OLS to take into consideration the dynamic effect and the endogeneity by using the fully modified OLS model, right? Or the CCR model or dynamic OS model, right? Of course, we won't share how you want to do it. Well, in a stat, if you use data or issue eView, you have a help file. So from help file there, you can actually see the command and how we do it. Or otherwise, nowadays we have AI, right? We always use the AI as our assistant and not replacement. So you ask your AI as your assistant, and you type in, and they say how I can run this fully modified OS using Stata. Can you give me the code? So I think they will give you lah, but I haven't tried before lah. Yeah. Then of course in finance data, usually you see finance paper got a lot of ash and gush. Why? Because very high frequency and high volatile data, right? So most likely you got heterogeneity. Mean uh, the error term got problem, right? So because of volatility clustering. So what you should do is you try to use ash and gush. Most paper you notice that they will stroke arch stroke gush because they are the same thing. Just that arch is a very long leg. You use leg 1, leg 2, leg 3, leg 4, leg 5, leg 6, maybe leg 10 and leg 13, leg 15. But you solve it by arch because arch they use the leg of the residue. So we assume that the residue, last year residue, also take into consideration of the last year, and the last year also take into consideration the last year. So therefore, you take into consideration of every last year. So you solve the long leg problem. Right? So let's give you some example. Ash versus gush. Okay. So what's the actual example? Will be, say, give you any actual example? No. You see, so ash and gush is actually the same, but just ash is actually take into consideration of the past volatility. Okay. Then of course another model will be ARIMA and SARIMA. ARIMA is just use one variable, univariate model, right? So sometimes by your objective, you want to see only one variable changes based on the past year, right? For example, you want to see what is the trend of oil price given past year, what's the trend of this stock market index based on the past stock market index you try to predict, right? So you just use only one variable, and then in this case, it's best used for ARIMA, right? ARIMA is suitable use for non-stationary, clear trend, but no seasonal pattern. If there was seasonal pattern, you just modify a bit and then use a seasonal ARIMA or called SARIMA. So far, it's a time series model, right? They still got a lot of time series model, but most common one, all these time series model will be, I believe that will be more than enough to cater for most of your research in your paper, in your thesis, your final project, or postgraduate thesis, or your PhD thesis as well. Then next, panel data, right? Sometimes why we use panel data, or sometimes why you use time series data, because some researcher or some examiner will question that why you choose this country. Let's say you choose Malaysia. Why you choose this country? You must say that I'm a Malaysian. But if you send this journal to a European journal, they say I'm not a Malaysian, right? So unless you say this country, you have a reason to choose this country, then it's okay. But then you choose panel data. But sometimes I noticed that time series data is more often get citation, right? You choose panel data, you choose all the country. then people will start also question you. You choose all the country, are they the same? Can you group them together, right? So of course, different model got different strength and weaknesses, right? But the most important thing is if you can choose the correct or at least a suitable model, you can answer most of the question, right? So some panel data, you can group it into static model and dynamic model. When we talk about dynamic in econometric, we are actually recognizing the past behavior. Static means just current, just like y equal to x1, x2, x3, right? All are in current term, t. Dynamic model could be y depend on previous y depend on previous x, or y depend on both previous y and previous x, like in the ARDL model. Okay? Okay. In a static model, of course, you start with the most simple one. OLS is a time series. So in static model, you use full OLS. I mean, you group all the country and run together as they are one. Right? That means like they are just a time series. So you run the pool of S is the most simple one. But in static model, most likely we'll report all the three and then we do a selection, right? So we run all the three, and then it's not that we select, it's we use a certain criteria to select, right? So you use a probability test to select between fixed effect FEM fixed effect model versus the pool OS model. You use the PPM test to select the random effect model and pool S model. You do the Horseman test to select the FEM versus IM. It's just like football league match. You got three teams, so each one A play B, A play C, C play B. So you see which one won more, right? Most likely, from my experience, pool LS, the most simple one, will most likely lose out. And if your data actually might consist of country that have specific fixed effect model, like Malaysia and US, it's very different in terms of level of development, sizes, then character, culture, economic structure. So most likely you'll get fixed effect model valid, right? I mean, this is the winner among the static model. So in short, panel model, you have static model. Static model, you got three model, which usually you do all the three, but you don't select based on your favorite or your choice. You select uh, uh, objectively using tests, right? You test. So let's say if fixed effect win, and then random effect win, then at the end, random effect and fixed effect will go to the final. So if let's say random effect win or fixed effect win. Okay? So after you do the fixed effect model, of course, the story don't end here. You have to go through the diagnosis test as well. So, right, but usually you have one or few diagnosis tests do not meet the diagnosis criteria, right? So it's okay. If you have fixed effect model, you can always choose the robust cluster. So you run again with the fixed effect robust cluster. So sometimes they report all the four model, full LS effect, random effect, and then robust cluster, and then they will analyze or explain based on the selected model. Okay? Now, dynamic model, as mentioned, you recognize the past behavior, right? So we basically have a few dynamic model. One is called short panel, right? Short panel, you just imagine the T, okay? The long T, I mean the horizontal is the cross section, right? The vertical, the leg of the T is time series. So if you have very, very, very few years only, and then a lot of cross section, so your T will be like one long horizontal and then very short leg. So you have short T panel. Therefore, short panel is number of N cross section more than number of T. But if let's say you have a lot of T, you can also make it become short panel by grouping them. By grouping them, let's say you got 50 years, you want it to be 5 years, you group 10, 10, 10, but 10, 10 is too much lah. But if let's say you take, of course, if you have available data for 50 years, you may only take 15 years. Each year you group three. Therefore, you got 5 group of years only. So in this case, you fulfill the short panel. Short panel, we have different GMM and system GMM, right? Okay. the requirement or the thing that take note if you choose dynamic model GMM, either different or system, is number of instrument must be greatly smaller than number of observation. In other words, if you want to choose a GMM model, you must make sure your N is very big. Otherwise, you most likely get a lot of weird result, right? Result or uh, insignificant, or you even got like instrumental problem, right? So you have to make sure that N is much bigger than the T. Okay? But you can also achieve it. I mean, you can also run it properly. If you don't have too much N, you can also achieve it by using high N or using a collapse command or specific lag selection. Right? This one you have to see yourself in the command in Stata. You can type a collapse command. I mean, they will automatically collapse some instrument that they think is not so useful, right? Or you specific lag length. You just specify only 2 lag length or 1 lag length. Then in this case, it will help you to make sure your number of instruments must be greatly smaller than number of observation, right? The number of observation will come from N. Need not do sensitivity test due to high emphasis on N. This one is still a debate area. Some examiner, you may get some examiner that insist that you still need to do stationary because you got an element of T right there. But for me, or you look at some of the paper, because the T is very short, most likely we are focused on the number of cross section. So therefore, stationary test may not be needed. Okay? But of course, if your examiner insists, and then you have no choice. Okay? Mean group. Then another one is long T, right? Of course, long T, most likely you need to do the stationary test. That means you have a lot of years, but only few company or few country only, right? So in this case, you use mean group or pool mean group. Actually, mean group or pool mean group is actually a panel version of ARDL model. So if you think ARDL is suitable for your data, but you are doing a panel model, then you use the mean group or pool mean group. The difference is theoretical reason to believe that relationship is the same. If you think relationship is the same, you use pool mean group, and if different, then you use mean group. Just like the fixed effect and a random effect. So you do both, right? But usually is people will do both together lah. And of course, alternatively, you can use a two-stage least square instrumental variable to do it. It's an extension of the OLS model, right? So you use the error term of the dependent variable to correct that independent variable. So there are a few more, but these few will be enough. If you want to do a panel model, most likely it will come under this one. Of course, there are many more, but these are the common one. Okay. Then, of course, we have some special condition, right? What do you mean special condition? We go back to just now, right? Your model selection not only depend on the characteristic of the data, whether stationary or not, uh, qualitative or quantitative, right? You want to do time series or panel or cross section, but also determined by the theory, right? Even though you do a diagnosis, then you might say they don't have autocorrelation, but the theory say that this type of situation will still have autocorrelation, right? When you have to also consider the theory and of course your objective, right? If your objective is to test the different relationship between different different group of people. For example, you want to test the relationship between the poorest and the richest, right? If you use any of the normal regression, you only give you an average. I mean, jump up together, you get one average, right? You cannot get a number for each group. So you have used quantile regression and other thing, right? Okay. Some of the special conditions that are common and useful model that you can use is quantile regression. So what is the objective? The objective is to test the relationship beyond just average, right? Like I mentioned. For example, you want to, let's say, you do an example, you want to see the overall marks in your class. So you just take overall. But this overall value do not give you anything. You want to improve their understanding. Then you might have to see what is the result of the highest group, lowest group, second lowest group, third lowest group, or first quantile, second quantile, third quantile, then only you can come out with different, right? So beyond the mean. And also it's good if you want to focus on the extreme case, because nowadays, if you see back 5 years or 10 years ago, right, all this inequity policy or government policy, they just used to say that a policy for the poor. But nowadays, in this recent 5 years, we are very frequent to notice those terms like T20, right? T top 20, bottom 20, top 10, bottom 10, especially the subsidized for the oil petrol in Malaysia. They particularly mention the top 10, top 20, right? So in this case, it's an extreme case. So the policy itself want to focus on the extreme case. And if you use the normal regression, you are just using the average, right? So you may not be able to capture extreme case, but if you quantile, it may be the bottom 20 may be the quantile 10, quantile 20. The top 20 may quantile 90, quantile 80. So you can see their relationship when they are top 20 or bottom 20 or top 30 or top 30, right? And by choice, best choice if the data violated the strict assumption of traditional linear regression. So if you believe that, or you go and test the data, remember or not, we have three characteristics to select your model. First is the characteristic and type of data. Second is a theory. Third is objective. So if you think your data actually cannot fulfill the assumption of traditional linear, right? For example, very skewed, not normal, right? Got outlier, clustering, heteroscedasticity, and many other things, then it's best to use quantile regression, right? Actually, one extra advantage, but you is quantile regression actually do not need to test so much on diagnosis test. Why? Because quantum regression do not assume normality. So most of the problem is because you assume normality, so the residual have to follow certain pattern and you have to test the residual. But if those models that do not assume normality, because like those who use the t-test, z-test mean they assume normality. Those who use the chi-square test, all this they do not assume normality. Therefore, they most likely will not need to go through so much diagnosis testing. And it also save your work, right? Another field is structural break, threshold, and regime switching. These three models, at first also, when I studied that time also, I quite confused with each of them, right? It's about the same thing, but you have to look carefully what is not the same. Now, structural break mean that the regression model have a permanent change at a specific point. Example, policy change. Right now, the government want to start from now have a new policy to go for environmental or renewable energy policy. So from now, or you have a oil crisis now because of closure of the Strait of Hormuz. Even though if the war in Middle East end now, right, the supply go back to normal, I don't think the whole economy will not be going to back to the normal like as usual, nothing happen, right? So in this case, it's a permanent impact. And COVID also, before COVID and after COVID. Before COVID, I remember I didn't use any e-commerce like Lazada, Shopee, but after COVID, we always use GrabPay lah, Touch and Go lah, Lazada, Shopee lah. So you see, COVID make a permanent change. So if this is the case, then you have structural break before and after, right? Of course, structural break, you can specific a known break, like which year as a COVID break, which year. So you have a known break, so you use a child test to it. Or you may suspect that there are several structural break, which is a bit hidden, not so common, right? So you may use another method to search for what structural break, what date and where, right? So it's got two different ways. One is you specifically mention the break, right? For example, you want to test international relationship with trade and FDI based on international relationship. So change on prime minister, change on policy, then this is your structural break. Okay? How about threshold? Structural break is permanent, but threshold is reversible. Threshold means that regression coefficient change if it cross a certain numerical threshold. So let's say it go over, let's say this A value. So you'll behave differently. then if you come back to less than A value, then you're back to normal. For example, how maybe maybe uh, inflation. I think of the case they use inflation. So let's say inflation is still low, 0.1%, 0.2%, 0.5%, 0.6%, 1%, 1.5%, 1.9%. Let's say until maybe 3% threshold. So within 3%, the Bank Negara may not be that aggressive in increase interest rate. Just slow and steady, wait and see. But after 3%, the central bank may behave differently, aggressively increase interest rate, do more thing, right? Act faster, act in a more magnitude. So you see different. But once the inflation drop back to less than 3%, then back to normal, everything as usual. So you see, it's reversible. So the structural break is not reversible, then permanently change, right? But usually involve a time of before and after, pre and post, right? But threshold is not, right? It's reversible. Then how about Markov regime switching? Regime switching, right? Regime switching usually we see in terms of two different era, right? For example, recession and expansion, right? Of course, it's also reversible, but you will actually group everything into recession one and expansion one, right? You will not see that the data move above or below. You will see like in more on the probabilistic distribution on that one. Okay, so so far so good. I have some of this uh, information I gather, right? So maybe I go share also this one to you all. Okay. On this one, panel data, static panel and dynamic panel. Last time I have done some training, so you may want to go to my YouTube and do and see how it's done in terms of practically, right? And also primary data or structural equation modeling, you can go to this equals for you, right? Static and dynamic panel, and then you also have this playlist. You put playlist, right? Panel regression using data, and then quantitative research using a few models that you have, right? And if you want to get the notes from today forum, you can go to my website www.harveman.com. You just click this Google site because I'm not yet update most of them. You just click Google site. Then you go to the last one, workshop and training. You can get this appendix and this PowerPoint to do this one. Okay. Powerful. Okay. So thank you for your attention.